guys, and you plug this into your L1. Also, because if you take a test, you can't see what you put in. I can't see what you put in. And chances are, if you're using these calculators, someone's going to write over it, or you may need it again in another table. Double check, God bless you, double check that you have the right amount of entries, God bless you. And I would double check that you have the right numbers in them. So X mean, whether it's sample or, and this one they want a sample, whether it's sample or population, your mean is always going to show up as X bar. So your mean for this guy, God bless you, should be how many more decimal places? I should round one more, but what are these? What are these numbers represent? They represent prices, right, in dollars. So I should really round to how many decimal places? 2. If you round to 1, not a problem, but because these are prices, round to 2. So you should have gotten this, right? Now, do I use my SX or do I use my sigma X for standard deviation? SX, why? Sample. Sample starts with an S. Use the SX. This is your sample standard deviation. And your sample standard deviation, again, should be the same decimals as this guy. So these are dollars. Now, to get your variance, this is the opposite of when we did those tables. Go to the word VARS. Hit the word VARS in your calculators by the clear button. Go down to number 5, statistics. Come to SX, hit enter, and square it. This will give you your sample variance. It's backwards from when we do the table. So your sample variance should be 422, 207.92. Now sometimes it comes out to a perfect number because if you think about our chart, we took the square root of a number. So sometimes it comes out to be a nice number, but you can't get to it if you just take this rounded one and square it. You will get close, but you won't get to the exact variance. If this said population, if this was a population, X bar would still be your mean. Which one is your standard deviation for population? The OX, right? The sigma X. This is your population standard deviation. Make sure you use the right one. And it's got an O, it's got an O. Kind of think of it like that. Okay. The second one, this one's trickier. This is your empirical rule. Where does this lie? Well, my empirical rule says plus or minus 1 standard deviation is 68%. You need to know these. Plus or minus 2 standard deviations, about 95%. And plus or minus 3 standard deviations is 99.7%. So therefore, how many standard deviations above the mean and below the mean do we need? 3. You could do this and start with your mean, subtract it, add it 3 times, subtract it 3 times, or make your sketch. I like the sketch because you get a chance to see it better. Put your mean here. Your mean is this, $70. Your standard deviation goes up 3, goes down 3. Put your standard deviations on the bottom, put your X values on the top. Your standard deviation is $14.50. So in your calculator, start with $70. Add $14.50. Keep adding $14.50. Then go in the opposite way, just subtract $14.50 each time. So now you wanted between the plus or minus 3. That's 99.7% of my data. So what X values are there? From 2650 to 113.50. These are the mean rates for satellite televisions, between 2650 and 113.50. So if I was a satellite company, I would tell you 99.7% of my customers pay somewhere between 26, because you're going to say, oh yeah, you're going to start me with a small bill, and I'm going to end up paying $200 anyway. And he's going to say, really? The most they pay is between 26 and 113.50. 99.7% of my customers. That's almost all my customers. I have a rare customer out here that uses a little bit more. I have a rare customer down there, would be very rare, who use even less than theirs. Can everybody do this? Plus or minus 2, we just go to the 2 one. And if you don't like to do it this way, you can start with 70 and just take 1450, multiply it by 3. Add 4350, and then take 70 and subtract 4350. It's a quick way to do it. God bless you. I do like you to do the sketches for me, while it takes a little bit of time. Okay, number 31. We're going to do number 31 together. Number 31 is a little bit different, and generally, a lot of kids have trouble with the Chebyshev's theorem. Okay, and I will tell you on the test when to use Chebyshev's theorem. Is the only time that we don't have a normal curve. We have a skew somewhere. Where? We don't know. So he has a formula, and this is his formula that you have to know. This is his formula. K stands for your standard deviation. Your standard deviation for him is either going to be a 2 or a 3. They can't estimate within one standard deviation. He can estimate for 2 and for 3. So the first thing we do is treat it as if it was a normal graph. You have 40 customers. This is N. And the mean is $36 with a standard deviation of $8. Using Chebyshev's theorem, at least how many means I need to have a number. How many of those 40 customers spent between 20 and 52? So I start like this. I need to know 20 and 52. Is it 2 standard deviations above the means or 3 standard deviations? So I just start like this. This is my $36. My standard deviation goes up by 8. So I say $44, $52. Oops, I hit it, right? So how many standard deviations above the mean is that? 2. It will also be 2 standard deviations below the mean. So what does this 2 represent in his formula? Well, he has one variable in his formula. K. This is the K I have to stick in here. I have to do this to find out how far above the mean it is. If I wanted to, I could start with my mean. I could add 8. This is 1 standard deviation. God bless you. This is 1 standard deviation. I could add 8. This is 2 standard deviations. Oh, I needed 2. The reverse of this will be symmetric. So -2 will have a 20 there. You don't have to go both ways. So I take this 2 and I plug it into his formula. He's either going to have a 2 or a 3. So 1 minus 1/4 is 3/4, which is 75%. 75% of all customers will spend between 20 and 52. Normally, my plus or minus 2 is 95%. But because he has a skew, but we don't know where it is, his estimation is, I can guarantee you, at least 75% of those people will spend between $20 and $52. Okay, now, it says how many of those customers. So I take this 75% and I multiply it by my 40. I need to know how many customers. And I get 30 customers. 3/4 of my customers. will spend between $20 and $52. I can guarantee you that. Even though it's not a normal curve, they don't behave normally. There's a skew somewhere. Maybe some like to stay a little bit, spend a little bit more, some spend a little bit less. I don't know where my skew is. But I can guarantee you, even with the skew, that you'll have at least 30 customers spend between $20 and $52. Okay? Did we get this? The hard part is this. First you have to do this. You have to find what your K is going to be. Then you're going to plug K into here. Normally, we just say what percentage. You stop at 75. If it says how many customers, you multiply it by your total customers. 3/4 of your customers. So 3/4 of 40 is your 30. Make sense? Okay. Number 33. Number 33 is a little different, and I'm just going to hit it briefly with you. Number 33 says, from a random sample of households. So I know I have sample. So I know I'm looking for a mean and sample standard deviation. Find the mean and the sample standard deviation. Now, we talked about this, we just didn't do one. It means for the number of households that have no TVs is one household. For the number of households that have one TV is 8 households. In other words, I'm like this, 0, 1, 1, 1, 1, 1. Then I have 13 of these guys, 13 of those. We put it in our L1. If we do this with the frequency, you do it the exact same way, but we say what when we do a 1 verse that? L1, comma, L2. Or on yours, it's going to say L1, and your frequency is your L2. Make sure you put a frequency. Everything else works the exact same. It's the same as if we strung it all out in one table. It's just a frequency chart. So try it. Try it in your L1 and L2. We talked about it, but I don't think we did any examples of it.
Now the middle stay away. Rest of it.
Is everybody okay with this? You can put it in your L1, L2. What did you get for your sample mean? 2.5. Good. One more decimal. Then the data. And your sample standard deviation? 1.2. Good. Okay, I want to spend a little time with this next one, because this wraps up our box and whisker and our interquartile. Clear out your tables. Everybody remember how to clear the tables out? Put this in your L1, please. And come down and give me your 5 summary numbers. Go down to the bottom and give me your 5 summary numbers. Everybody come up with a min? 42, a quartile 1. Everybody getting these? A median? Quartile 3? And a max. Good. Everybody can find these. Alright. Let's do the box and whisker graph first, and then we'll do the interquartile range. So I have a title. These are Harley and miles per gallon of double motorcycles. We'll just call it Harley miles per gallon. I need to go from here to here. So what should I start my number line at? What's a good place to start? 40. And what should we go by? You can go by 2s. That might work. So I only need to get to 60. So 42, 44. Perfect. Now, remember, first I want you to do is plot all those points above your number line. Don't put your box and whisker on your number line. So I find 42, I put a dot. I find 47.5, I'm very close to 48, just put a dot. My median 53, I'm between my 52 and 54. My max, 60. Whoops, did I miss one? My quartile 3 is a 54. Look at how close those are. And look at my max. The middle 3 is your box. And these guys are your whiskers. They're separated into quartiles. Each one represents 25% of your data. So, of these sections, which quartile has the smallest variability? 3, right? Because it's the closest together. The smallest variability means your data is very, very close together. You have the smallest standard deviation. Remember that too? When we talk standard deviation, variability is your standard deviation. Your data is very close together. If we're looking for the largest, we could subtract and see where they come out, or we could count the boxes. I think it's pretty between the 1 and the 2, they might be similar. Okay, they're kind of good, but this guy definitely has your smallest variability. And when you do a curve, you're closer to, remember when we did the curves? If it's closer to the mean than this, and this one's a little more like this, same mean, smaller standard deviation. Question or stretching? Stretching? Oh, that's okay. Now, interquartile, you're only given 2 numbers here, 2 things with Q's. So, the larger one minus the smaller one. Subtract those first for your interquartile, and then take this and do what? Multiply it by 1.5. Your interquartile range is this. It is this. It is 6.5. For us to find an outlier, now we're going to take your interquartile range and multiply it by 1.5. If you multiply 6.5 by 1.5, what do you get? $9.75? Thank you. You're my go-to guy, Chris. Now, this is what this means. I take my quartile 1 and I subtract 9.5. So my quartile 1 is 47.5. If I subtract 9.5, I get 38 over here. Is it less than, does my minimum fall within that? Right? My minimum falls within that. Nothing falls outside of that, right? So I have no outliers on the left-hand side. I do the same with this. Remember, you're only given 2 quartiles to work with. Work with the Q's. I take my quartile 3, which is 54, and I add 9.75. This is going to give me 63.75 out here somewhere. Do I have anything that lies out here? I have no outliers. If it fell here, then this guy would be an outlier. So use your box and whisker graph to see where it falls. Okay? And last, everybody should be okay with this part. Laying these out, finding your z-scores. Can everybody do these? Let's see if we can hit this real fast. The towing capacity, whoops. Okay. Has a bell-shaped distribution. Again, we start like this. Put your mean in the middle. 1, 2, 3. -1, -2, -3. This is going to help you know this formula. I will give you this formula tomorrow. But that's the formula you're going to use for this. Put your mean. I realize the numbers are large. You're going to add your standard deviation all the way up. So if you're writing this down, this comes out to be 142,000. Sorry, 14,200. This comes out to be 16,570 and 18,940. Going down, 9,460, 7090, and 4720. This gives you a good reference. So if you want to find these guys, use this as your reference. If this is going to be my X value, 16,500, I notice it falls right before this guy. So I know my z-score is going to be positive, right? And I know I'm going to subtract, therefore, my larger one, which is my X value, minus my smaller one, which is my mean. Because I need that to be positive, and I'm going to divide it by my standard deviation. This is going to give me my z-score exactly. And I should see my z-score come between 1 and 2. Okay, so I do the math, and I come to 1.97. Didn't we figure it would be that? Now, if I'm looking for the percentile of this particular truck, how many percentage of the trucks are he larger than? I would look this up in my chart. I'm going to look up 1.9 and 0.07. And I'm just going to move the decimal 2 places. It should be a good chunk of an area, shouldn't it? Because it's well above the halfway mark. It's almost to 2. That's a lot of my curve. So can we do that? All right. So tomorrow's the test. If you